The key feature is that you're trying to get these energetic sources to increase flux back within certain regions of the brain that might have high resistance. So perhaps like looking at psychiatric illnesses as these local hotspots of high resistance for whatever means, whether it be metabolic or whatever sources, then you have a whole new set of tools to reprogram that resistive state. So perhaps can we conjecture that psychiatric illnesses could be a resistive state, like an actual energetic resistive state?
Excess energy resistance.
Excess energy resistance. And why, unlike a heart attack or a stroke, why these psychiatric states manifest behaviorally or subjectively as different responses, because the brain, being complex, is tuned to modulate that resistance in very different ways. So
to ground this in the brain a little more, maybe I think some of your Mind and Matter listeners will resonate with this. There are different large scale brain networks, right? Like the optimal network, the salience network, the attention ventral dorsal attention networks, There's this beautiful new paper from like 2 weeks ago, I think, Parker Kelly, who's a mitochondrial psychobiologist at UCSF, who does some work on psychedelics and mitochondria. He's come up with this beautiful ATP model, which is about thinking energetically on how the brain manages energy. And if you have a neural network that's activated, right? This is maybe the way that the brain has to decrease energy resistance in one network. But to decrease energy resistance somewhere, you increase energy resistance somewhere else, right? So the way that the brain generates these complex energetic states or complex energetic patterns that we see with fMRI, that we see with EEG, right? All of these modalities, they image energetic states of the brain. Parker was thinking about this from an energy constraint perspective. And what we know is that at the whole brain level, there's a fixed budget. The brain receives a certain amount of blood, so it has a certain energy budget. And if it's going to hyperactivate something, it needs to suppress something else, right? And then there's always these kind of
push-pull dynamics,
right? Something is turned off for something to be turned on. If you chronically turn something on and you chronically turn something off, what happens is if you turn something off repeatedly and you basically decrease blood flow and activation there, that thing is going to atrophy, right? The same thing that if you put a cast over your arm or over your leg, that muscle is going to shrink. This is, if you increase energy resistance, energy can't flow in that direction. If energy can't flow, then that part is biologically means it's not useful. It shouldn't be sustained, right? There's less transformation there. So then you get catabolism, the breakdown of stuff. So the same thing could be happening in the brain. The brain has this budget, and if you chronically move the budget towards like the salience and the threat network, then you're deactivating other parts of the brain that are, involved in creating attachment to other human beings or, thinking positively about the world, about yourself, right? Then those things atrophy. And but that's not like a neurotransmitter first process. This is like an energetically driven process.
It can explain why psychedelics have such a profound response, right? Because you're redistributing that resistance, a resistive network. So I think you have the brain energy network that people usually compute in neural networks, but then you can actually perhaps compute a resistive network, and therapeutics can basically modulate that resistance.
We could talk for a long time about psychedelics. But just I wanted to ground this in the symptomatology, and the ATP model is about psychopathology, right? And Parker's model about like energy moving around in the brain and things being deprioritized, energetically deprioritized.